so we're going to, you did the videos and thank you very much for your efforts on that. Some of you did really well, so well done with that. Now we're going to sort of pick up from that and use the notes that you got today to start working through and get practice on what you need to know and so on. Okay, so what you're going to have, and I put this on Google Classroom, is the notes, and you can access the revision book as well, if I can share that. Okay, so the chapter from the revision book is here. Now most of it is double award. I don't think any of it is discrete chemistry only, but we'll keep an eye out for that. Okay, so let's have a look at the definitions in the notes first. Work our way through it. So stop sharing that. Go back to the notes. Okay, so first thing is definition of oxidation, right? So key thing you need to know is what the definition of oxidation is. So it can be defined in 3 different ways, right? 2 of them are foundation tiers, sort of more simple and straightforward ways of talking about it, and then one of them is the higher tier. Now, hopefully I should be able to write on this. Okay, so what we've got is the definitions are oxidation is a gain of oxygen, right, or it is the loss of hydrogen. Now you might have both gain of oxygen and loss of hydrogen in the same reaction, but you can say if you see a compound, an element gaining oxygen, or a compound gaining oxygen, or a compound losing hydrogen, right, that is oxidation. Then reduction is the opposite of that. So reduction is the loss of oxygen, or I should say, it could be the gain of hydrogen. So you need to watch for that. And actually, if oxidation happens, so does reduction. So a redox reaction is one in which both oxidation and reduction occur. Now I'm going to switch over to the revision book just to show you some examples of this, hopefully. Okay, so if we look, there's the 3 definitions, right? Okay, and this is the higher tier one that we get to eventually. Okay, so you've got, right, so this is good. This worked example here. Explain why this reaction is described as reduction. Now, I'm going to just share, so it's H, right, I'm going to share my whiteboard for this. Okay, so let's have a look at that reaction they had. It was hydrogen and chlorine giving hydrogen chloride, right? So what you had was 2H2 plus, it was H2 plus Cl2 arrow 2HCl. Okay, so everything balanced that way. Now, if you look at this, it's this is a straightforward one because it's not obvious that both oxidation and reduction are occurring, although they are. Okay, so let's have a look at what happens to each of the reactants. Now, there's nothing obvious happening to hydrogen in terms of oxygen and hydrogen, so you can't say that it loses or gains, right? So nothing obvious happening there. So let's have a look at the chlorine, right? So if you look at chlorine, okay, as you go over to hydrogen chloride, you can see that it gains hydrogen, right? We've just seen that the definition, now is that oxidation or reduction? I'll have to think of this. So if a substance gains hydrogen, it is reduction, right? So chlorine gains hydrogen, and gain of hydrogen is reduction. Okay, now if we go back to the revision book and see the other example there. Okay, so you can see there for part B, it says magnesium burns in air according to that equation, right? And again, if you look, you've got the magnesium has gained oxygen, right? So it's become chemically bonded, I suppose, chemically bonded to oxygen, right? So the gain of oxygen is oxidation. So you can explain that. So they've got here, and then you've got the other alternative that we haven't mentioned yet is about redox reactions in terms of loss and gain of electrons. Okay, so if we go back up here, we'll see that oxidation is the loss of electrons and reduction is the gain of electrons. Now I should say that that is actually the most fundamental definition, right? It's always true. You will see as we look at, say, metal displacement reactions, that even though they are redox processes, there's no oxygen being lost or gained, or no hydrogen being lost or gained. So you have to talk about it in terms of electrons. So oxidation is loss, and reduction is gain of electrons. Now, if you look at the notes, I have it as Leo-Ger as a sort of mnemonic to help. So Leo is lose electrons oxidation, and Ger is gain electrons reduction. However you remember it, try and remember it. It does get confusing, even for me who's been doing it for many years. Okay, so we're going to go to the notes now. So what I want you to do is have a look at your notes and try and fill in the blanks right at the bottom of page 1. So pause at this point and have a go at filling in the blanks there. So that's thinking about it in terms of oxidation reduction, electron loss and gain, and hydrogen loss and so pause the video, do that, and then check the answers next. Okay, I apologize if you can hear that background noise, it's the dog. Okay, so if we look here at the answers, right, so just iron and oxygen and water gives you hydrated iron 3 oxide. Now, hydrated iron 3 oxide, so you will need this in the future, that is the chemical name for rust. You'll see that coming up in this topic, right? But anyway, here you have iron gaining oxygen. The gain of oxygen is oxidation, so iron is oxidized. So that's kind of standard answer for that type of question, right? And for combustion, see the carbon loses hydrogen, right? So CH4 becomes a CO2. So you can say it loses hydrogen, or you can say it gains oxygen, right? It's done both, right? And those are both exact. So reduction has happened. You can explain it either way you want. And therefore you can say that carbon or methane has been reduced. It doesn't really matter if you talk about carbon or methane in this instance, right? You can, it's the easiest to say, use the chemical formula sometimes, like CH4 is reduced. Okay, and the last one, reduction reaction. So you've got aluminium here. Aluminium loses oxygen, the loss of oxygen is reduction, and aluminium is reduced. See that? Let me get that tuned in a bit better. Okay, so if you hopefully have done the top of page 2 as well. If not, oh no, page 2 is something more. Okay, now we're going to talk about the more advanced, if you like, the higher tier definition of oxidation reduction, right? And it just happens, although it's not really obvious in some of the examples we've seen so far, that where there's oxidation, there must be reduction. And if you look at the definition of oxidation and reduction in terms of electrons, if one substance loses electrons, another substance must gain them. Okay, so we've got redox process, right? The loss of electrons is oxidation, right? Lose electrons, oxidation. Gain of electrons is reduction. Okay, so Leo-Ger and lose, incorrect spelling there. Okay, so I'm going to just put that down a wee bit more. Okay, so we're going to look at metal displacement reactions. Now I'm going to play you a bit of a video, and we'll pause as we go just to see if there's any clarification needed. Okay, so we're going to play this video, right? Just get it up and running. It is hopefully will explain things nice and concisely.
Hi and welcome back to freesciencelessons.co.uk. By the end of this video, you should be able to explain what's meant by oxidation and reduction in terms of electrons. You should then be able to identify oxidation and reduction in half equations or in simple equations. All of this material is for higher students only. In the last video, we started looking at displacement reactions, such as this one. We saw that a more reactive element will displace a less reactive element from its compound. In this, because magnesium is more reactive than iron, it displaces the iron from the iron oxide. The iron atoms have been reduced as they've lost oxygen. The magnesium atoms have been oxidized as they've gained oxygen. Now,
okay, I'm just going to show you the, no, I'll leave that play.
Now, in this video, we're looking at another definition of oxidation and reduction. This one involves electrons. Oxidation is the loss of electrons, and reduction is the gain of electrons. Here's an example to illustrate the idea. We've got a magnesium atom forming the magnesium ion, Mg2+, and 2 electrons.
Okay, I want you to have a think about this, right? So in this instance, there is electrons being lost from a magnesium atom. Now, magnesium has 12 protons, so it has 12 electrons in the atom. And the magnesium ion still has 12 protons, but now it only has 10 electrons. It's lost 2. It's got a full outer shell. Okay, and those 2 electrons are released as, they're kind of written as a product. Now, they will go over to something else, but this is just a half equation. It's showing what's happened to half of the reactants in a way.
In this case, we can see that the magnesium atom has been oxidized as it's lost electrons. Scientists call equations such as this one a half equation, and we're going to be seeing these again in later videos. Here's another example. Here, a sulfur atom has gained 2 electrons and formed the sulfide ion. We can see that in this case, the sulfur atom has been reduced as it has gained electrons. Now, there's a fairly easy way to remember this. Think of the words oil rig. Oxidation is loss of electrons, and reduction is the gain of electrons. Here are 2 examples for you to try. Pause the video now and work out whether these are oxidation reactions or reduction reactions.
Okay, so the video has been paused. So just think, has the reactant substance on the left, has it got more negative? In other words, it has gained electrons, or has it become more positive, has lost electrons? Okay.
Okay, so this half equation shows an aluminium atom losing 3 electrons to form an aluminium ion. Because the aluminium atom has lost electrons, this is an oxidation reaction. This half equation shows an oxygen atom gaining 2 electrons to form an oxide ion. This is a reduction reaction, as the oxygen atom has gained electrons. Okay, now you could be asked to identify oxidation or reduction reactions in simple equations. Here's a typical question. Identify in the reaction below which atom has been oxidized and which has been reduced. This shows zinc reacting with copper sulfate to form zinc sulfate and copper. This is a displacement reaction. Now, in order to answer this question, you need to know the ions present. So I'm showing you these here. Pause the video and try this question.
Okay, folks, so try and think what has kind of become more negative or less positive, right? What has gained electrons and what has lost electrons?
If we look at the zinc, we can see that we start with the zinc atom Zn, and we end up with the zinc ion Zn2+. In order for this to happen, the zinc atom must have lost 2 electrons like this. Therefore, the zinc atom has been oxidized. Looking at the copper, we start with the copper ion Cu2+, and we make the copper atom Cu. For this to happen, the copper must have gained 2 electrons, In other words, it wasn't huge. Remember, you'll find plenty more questions on oxidation and reduction in terms of electrons in my Vision workbook. You can get that by clicking on the link above. Okay, so hopefully we should be able to explain what's meant by oxidation and reduction in terms of electrons. We should then be able to identify oxidation and reduction in half equations or in symbol equations.
Okay, so now what I'd like you to do, I think, is before we move on, is have a look at page 2 of the notes, right? So in that video, stop sharing. So in that video, the speaker talked about half equations. Now that's kind of confusing. So I think what you need to recognize is in a half equation, you're going to see electrons, right? They're going to be part of the chemical equation, whereas regular chemical equations and ionic equations don't show electrons at all. Now, I need to share. Okay. Okay, so page 2 of your notes, right? It's talking about a different metal displacement reaction. So what I think you should do is have a look at this and see, can you work out what has been oxidized and what has been reduced. Now, just one thing to bear in mind is any metal that becomes part of a compound will have to have a positive charge. Remember, metals always lose electrons when they're in a compound, or they always have a positive charge in a compound. And any element has no charge at all, right? Because it has the same number of protons and electrons. Okay, so if you look, the answer to this is down below. Right, so in this instance here, magnesium atoms, right, become magnesium ions. So they must have lost electrons to form a positive charge. And remember, loss of electrons is oxidation. So the magnesium atoms have been oxidized to magnesium ions. And we show that with the electrons being produced, their product. Now, in this instance, you're starting with copper ions. It happens to be copper 2+. You can look on the back of the data leaflet for the charge of a copper ion. And it becomes copper atoms, right? So it's gained 2 electrons, right? So the copper ions gain electrons, they gain 2 electrons, and that by definition is reduction. Okay, so I think before we move on, get some practice on this and turn to page 50 of your notes. There's some questions here from the revision book. Okay, so what I would like you to do is try questions 1, 2. We haven't got to that yet, or we haven't done 3 and 4 yet. And try 6, 7, 8, and 9. Okay, so pause at this point and take some time to do this. This is pretty challenging, all right, particularly ionic equations. So if you don't know those, again, I think that do not spend a long time trying to work out ionic equations and so on, probably A star stuff. And, you know, you will need to know them if you're going to do A-level chemistry. But other than that, you can probably do very well without getting those sussed out. Okay, so pause at this stage and have a go at those. Okay, so I'm going to go and through the answers to these, right? Explain why, I never like the word how you know, I think it should say explain how you know nitrogen is reduced rather than why. Okay, so how you know nitrogen is reduced is because nitrogen gains hydrogen and the gain of hydrogen is reduction, right? The following gases, which is gained in a reduction reaction. So hydrogen is gained in a reduction reaction, which is gained in an oxidation reaction, it's oxygen. Okay, as I say, we haven't done 3 and 4 yet. Actually, we could have done that one. Complete the following paragraph. Oxidation is the gain of oxygen. and the loss of electrons. Reduction is the loss of oxygen. Oh, we have some of them repeated. It's the loss of oxygen and the gain of electrons and hydrogen. Okay, don't have to use them all. Right. Okay, so question 7 I'm going to do here. Right, so question 7. It says the zinc is converted to zinc ions and copper ions are converted to copper atoms. Write a half equation for the zinc atoms to zinc ions. Okay, so tricky enough, right? So converted zinc atoms are the reactant. So we're going to start with zinc as a reactant, and it says it forms zinc ions, and you can look on the back of the data leaflet to know what the chemical formula of zinc ions are. It's hard to tell because they're in the transition metals. And then it says conversion of zinc atoms to zinc ions. Okay, and we're going to need to put electrons in. So they're produced, right? And there's 2 of them. So you'll always have whatever charge you have here, you're going to have the same number of electrons, right? Okay. So, and they have to add up. This adds up. This has no overall charge. So these 2 must add up to 0 charge as well. Okay, so that's that one. And that's A. And then B, write a half equation for the conversion of copper ions to copper atoms. So you're starting with copper ions this time. Again, back of the data leaflet. So it's copper 2 plus. Oh, they did tell you it's copper 2 sulfate. And you're going to make copper atoms. Okay, so this time your electrons are going to be over here because you're adding them in. So I suppose you, okay, this was, I don't say that in case it's not true, that the electrons are always on the side of the ion, positive ion, maybe not, we'll think about it, have a look for that. Okay, so there's your 2 half equations, and now it's asking you which one is oxidation. So we know that oxidation is the loss of electrons. Okay, so this has lost electrons. So this is the oxidation half equation. And then by this must be the reduction half equation because there is the gain of electrons. Okay, for 8, write the half equations for the oxidation reduction processes and label them as oxidation reduction. That's a vile question, but we'll do it anyway. Okay, so you've got Mg plus 2HCl gives you MgCl2 plus H2. Oh, this is now advanced. Okay, so we'll go through it, but I don't know how likely this one is to come up. Because this is a metal with an acid giving you salt and hydrogen, and this is from 4th year. Okay, so let's have a look. We're going to actually, right, we've got magnesium. Let's do the easy one first. Magnesium atom giving you magnesium ions. Okay, so let's put magnesium gives you Mg2 plus because it's group 2. We're going to put the electrons on the same side as the positive ions, the same number of them. So that is one of the half equations. Now it's not really obvious what the other one is. Okay, but it is actually hydrogen. Now you know that because hydrogen, it's forming the element here and it was in a compound here. And hydrogen in hydrogen chloride or hydrochloric acid, right, is a H plus. So what we've got is H plus, 2 H pluses over here, and H2 over here. And each of these has gained an electron each. Okay, so yeah, that's tricky. Okay, so this one's more straightforward. We have lost electrons, so that is oxidation. And this has gained electrons, so this is reduction. Okay. And number 9. So in that ionic equation, this should be easier to spot. I'll just write it out. So it's Mg plus Zn2 plus gives you Mg2 plus plus Zn. So hopefully that was easier to recognize than the last one. So this time, this is kind of like the example in the video. Got mg, let's do our half equations. So we just take each element in turn, giving you mg2 plus, and that must have released 2 electrons, right? And then we've got the Zn2 plus, giving you Zn, and that must have gained 2 electrons, because you can't just, because like, you know, you need 2 electrons to get the atom back from the ion, and loss of electrons. So this is the oxidation, and this one is gaining, so this is the reduction. So the more reactive metal will always be oxidized, and the less reactive metal will be reduced in these. This is a representation of a metal displacement reaction. Okay, we'll stop the video there.